Hey there, I'm Daniel Markham. I wrote the domain model for domain modeling. And this week I'm going to do something a little different. I'm going to tell you what I'm not going to do. I had planned on working with a friend of mine to do some incremental strong typing, which I don't think anybody else is doing. People seem interested. I want to do it. It's cool stuff. But my friend's not available. So what I thought I would do instead is tell you what I had planned on talking about before we started the actual coding back and forth. And then when my friend becomes available, we'll do the extra nerdy stuff. This kind of started in the conversation around microservices and best practices, and it evolved from there. I was simply explaining to my friend how I do programming, and he didn't grok it. Didn't make sense to him. If you see on the right hand side of the screen here, I actually have some code up. Basically, this is way overtyped, but I wanted to point out to him that I wasn't going anywhere, that the functional community wasn't going anyway with the domain-driven design. But my point being, you don't have to strongly type if you don't need it. So on the left-hand side here, we have sort of smells that I use for incremental strong typing. I never do anything that causes input or output in the same function that processes data. They're separate kinds of things. I think by mixing them up, no matter how you do it, whether you use monads or just direct system calls, you'd be headed for a world of trouble, dudes. And the reason why is that you end up cascading a lot of I/O and other air condition validation issues, all kinds of crap just sort of cascades throughout the code to some point where you're making a decision about everything. And that's probably not the spot you would be thinking about what those conditions should do. So you lose cognitive focus. A lot of this is around sort of managing what you can stick in your head at one time. Never create an attribute on a type that's not used somewhere else in the code. So this is what I mean by incremental strong typing. For instance, if we were asked to sort a set of strings in a text file somewhere, well, of course, I'd just sort it using the unit command, but let's say that didn't exist. We would just pull in line by line and sort it. It would still be trivial. But if that text file had customer data or invoice data or something like that, we'd still pull in a line of strings and sort it. So just because we know there's underlying type information somewhere, we don't need to use that in our code. We don't add it. Incremental strong typing. Always deal with I/O and validation errors immediately in the code that reads or writes to the outside world, which is sort of a redux of number one. So you should never crash. I mean, once you get past here's the stuff I need to work with, you should not crash. So if you need memory allocation, you need data validation, whatever you need, do that, and then work with whatever you have. Only use types alongside force matching for code branching. So this may require a little bit of explanation. Basically, in some functional languages, you're allowed to create a algebraic type or a type that has sort of multiple options on it. OO would be polymorphism, sort of a similar idea. And you're not only allowed to do that, you're also allowed to tie that in with your paths in your function. So, it's either this or that or the other thing. And if you add a new thing to it, the compiler will actually tell you that you've missed a spot somewhere, which that doesn't happen in polymorphism. So what this does is allow our types to actually control the flow of the code, which is actually way cool. No mutable variables. I put that in because it's a code smell for me. I found early on in my F# programming, I would sort of write for loops. I would do all sorts of different things that were basically C# or C++ or cross-compiled into F#. But whether your language supports mutable variables or not, to follow along with this little thing, don't use them. And a lot of reasons for that. It has to do with side effects outside the scope of the person programming. Dodo, do one thing only. If validation or data errors create a situation where a system decision must be made, you have a separate function. This is just good function writing. If it creates a business decision, you probably have a separate application. That's new, okay? So, if I were given a task to sort the set of strings, and I just had to use a programming language, I did a set of strings with a sort, and then the requirement was, well, for every one that starts with a T, I actually want to do this other processing. Well, now we're actually talking a business change, right? So that's a different, business changes are different than system changes. And you need to understand that when you're doing the writing your code. Whereas in the O world, you're actually sort of modeling the thing you're working with, and then business decisions sort of go there, right? In the functional world, you're just sort of processing the minimal amount needed to get from point A to point B for one business customer. Right? You could call that a user story if you wanted to. And then if you have a new thing, you actually have a different thing to do. And that different thing may have different requirements and all sorts of other things. Never fail. So I'm a strong believer in error-free programming. And if you've got something to do it. If you can't do it, just come back to me with nothing. I don't. It's not my problem. I'm a caller to the function. I'm not worried about what you're doing inside of there. That's the whole purpose. So you can never fail. And the last two, I just sort of put question marks next to this, and this is all tentative. I'm not writing a Bible of functional programming. This is my conversation with my friend. Always test at the outside of your app loop, and so whatever your application does, it does it on a sort of a vector basis, and outside of that vector, you should always test. New thing is what you publish is the test, right? So whatever you say your application's doing, that's what others need to know, not your code. I really don't care what your code does. Your tests show that your code's working correctly, and that's the thing you share with your team. It's a different way of looking at code sharing. It's actually much more scalable than sort of moving around thousands of lines of code and having these long build cycles. It's ugly. Finally, the goal is an application that works like a pure function, and I call that a microservice. So if you follow these sort of code smells and along with all the other good programming stuff, you end up with an application that works like a pure function. You throw it in a flow somewhere, it does what you want it to, it doesn't fail. All of those things we talked about each function doing, your application does. That makes it composable at the OS level. It also makes it composable, by the way, at the code level. So I'm not trying to tell you to write console apps. Oh my God, no. What I'm trying to tell you is that if you write a incrementally strong typed application, it works anywhere. I don't care if it's a message queue or you've got a UI. None of that implementation stuff matters, nor should it matter, right? So this thing we keep talking about, separation of concerns from UI, from business application, from testing. These are great things. We seem to fail doing that quite a bit. So a lot of times I'm in a UI and I end up with a programming UI code error on the back end, or we get this stuff all kind of muddled together. And especially with the beauty that is dynamic link libraries and the beauty that is pure functional programming, we actually can have pure separation now. And that means all sorts of cool stuff. You can drop this into Elm or drop it into some other application. Actually, with .NET, you can drop it anywhere you want. These code smells are not language dependent, but they do enable language independent sort of programming. There's a whole other conversation about composability of functions, and there's a dozen other conversations. I'm looking forward to having these conversations when my friend gets some time. Anyway, so thought I'd show you what I'm not doing this week. It's going to be a hoot. It's going to be fun stuff. I love pair programming. I am Daniel Markham. I will see you on the internet.